Welcome to a lesson with Dr. Powell. Let's take a look at taking a determinant of a 4 by 4 via just sliding, meaning adding one row to another or a multiple of one row to another. It just kind of slides the shape around, maybe even interchanging coordinates, but doing nothing more than that. We're not going to rescale any particular coordinate. All it's going to do is just going to slide the box into be rectangular, and then we can look at it. And actually the determinant will pop right out very quickly. So we're just using row and column operations. Right here, if we multiply or we just take the top row and add it to the second row and the fourth row, we end up having zeros underneath this one. Then over here, we can use the idea that we have a 1, 0, 0, 0, multiply this by things to come over here to make these zeros, and nothing else here is affected because it's just 0 added to things. So really, if we have a 1, 0, 0, 1, 0, 0, 0, we can use a column action to just clear out the rest over here. All right, now we move down here and we're going to try to get a 1 right here, which we can do by just taking a negative of this row and adding it to that row right there. So we have a 1 right here. Then from there, we can use this 1, multiply it by -2 and add to this guy to make that guy a 0, which is what we have here. And then we'll get a -2 here and a 6 here because we have -2 times 3 is -6 plus 4 is -2. And -2 times -2 is +4 plus 2 is +6. Okay, now since we have a 1, 0, 0 and a 0 up there, using again a column action here, we can, for the same reason we could clear that row out with zeros, we can clear this one out. So we end up getting 0, 0. All right, now from there, we're just right down here. Now, automatically we notice, hey, if we just add these, replace the bottom, we have a 0 right there. That looks great. Okay, see this 1? It'd be nice if that 1 was over there. We're not going to divide by anything, remember, or rescale. So we're just kind of using these other types of operations, which actually work great. And it is possible because of the Euclidean algorithm among the integers, you could actually always eventually get down to a diagonal. So why don't we just switch these? Let's switch 1, 7 here. And so we have 1, 7 and 2, 0 right here. That's good. Now let's use this 1 to play against what's below it. And doing so, multiply by -2 gets rid of that because, not -2, but by -7, sorry, times -7, out of that, it becomes 0. -7 times 2, -14 comes down there. We are very, very close. Now we can just, oh, look, we have 0, 0, 1, 0, column action, clear out the 2 over there to make a 0. And voila, we end up with a diagonal matrix. We have successfully kind of shifted and maybe turned our orientation by switching coordinates. So we see this this rectangular in space, and we could talk about its volume perhaps if we were thinking four-dimensionally, and the negative just accounts for a negative viewpoint or oriented view. Now the determinant actually is a +14, and that's because we changed our viewpoint orientation just one time with one switch of columns. But the determinant will be +14. We could have known that but we could have just taken the absolute value will be 14. And we know that this particular method preserves absolute value. Notice we never rescaled any row or column, and we were able to get the determinant just by sliding. Thanks for watching.